Greetings Calc 2 students. This video is for section 7.7 and specifically talking about the trapezoid rule. The trapezoid rule comes from when we take the left approximation endpoint and add it to the right approximation endpoint and divide it by 2. That average then takes this curve that we've been looking at before underneath the area underneath that curve, and it makes trapezoids. So instead of having rectangles and summing them up, now we're taking trapezoid 1 plus trapezoid 2 plus trapezoid 3 plus trapezoid 4, or trapezoid 5 and 6 and so on until we have n number of trapezoids. And you'll notice that these are not rectangles, these are trapezoids. So the base is flat, but the top has this slope to it. So that's why it gets called the trapezoid rule. Okay, so let's take a look. T sub n, so n is the number of subintervals, and the formula algebraically for the trapezoid rule is delta x over 2, and then we evaluate x initial in the function plus, and then we evaluate x endpoint, the endpoint in the function. We add those together. And then all of the points in the middle, so x1, x2, dot, 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 all the way up to xn minus 1, we add all of those up and we multiply those by 2. So the endpoints, we do nothing to those, we just add them together. And then all of the ones in the middle, we add them up, but we multiply those by 2. When we sum that all up, then we multiply that by this delta x divided by 2, where the delta x is equal to b minus a divided by n. So that's the change in x. And then our xi intervals, each of these, is found by taking our a value, so our initial value, plus the ith times the change in x, delta x. Okay, so let's look at this example that we've been talking about, y equals x squared, evaluated from 1 to 4. So we could do that by setting up the integral from 1 to 4 of x squared dx, and we would get that equal to 21. So we want to approximate that using the trapezoid rule with 5 subintervals. Shorthand, we would say that that's T5. So n equals 5, that's the first thing I'm going to point out. So how many subintervals do I have? I have 5. And then my delta x is b minus a over n. So that's my endpoint, 4 minus 1 divided by 5, I get 3/5. Then I like to make this chart of my subintervals so that I don't get confused or lost when I'm writing out the rule. And it's important to remember that I should start at the first place. I should start at the 1. And when I have all of my intervals, so I have n equals 5, when I finish, my x sub 5 should be at the end when I'm doing the trapezoid rule. So let's see here. I'm starting at x naught, which is 1. That's where I started. And for x1, I'm going to do a plus 1. So this 1 goes to, or comes from that 1. So a plus 1 times delta x, which is 1 plus 1 times 3/5 for 8/5. And then x2 equals a plus 2 times delta x. So 1 plus 2 times my 3/5, my delta x, I get 11/5, and so on. So x3 is a plus 3 times delta x, 3 times delta x, add a for 14/5, and x sub 4 is a plus 4 times delta x, so 1 plus 4 times 3/5 for 17/5, and then finally x sub 5 should be 4 when I'm finished, so I get a plus 5 times delta x, so I get 1 plus 5 times 3/5, so I get 20/5, and 20 divided by 5 is 4. So sure enough, I have 1 to 4. So that's tells me I've got probably the correct list. So then I have x squared integrated from 1 to 4 is approximately equal to the trapezoid 5. And that again is delta x over 2 times. So I'm going to put x naught in my function, and I'm going to add it to x sub 5 in my function. Then I'm going to take x1 and x2 and x3 and x4 and plug those in individually into the function, add them up, and then multiply by 2. So here we go. Delta x is equal to 3/5, and I'm going to divide that by 2. And then x naught was 1, so my function is f equals x squared, so 1 squared. And then I did it over here again. I took 20 divided by 5, which is 4, and I squared that. Those are my endpoints. I just plug those into the function. Then all the things in the middle, I'm going to plug each of those individually into the function and then multiply by 2. So I put 8/5 into the function, and so then I squared 8/5, and I add it to 11/5 and squared it, and 14/5 and squared it, and 17/5 and squared it. Then I sum all of those up and multiply by 2. So in the next step I've simplified. 3 over 5 divided by 2 is 3/10, and 1 squared is 1. And of course 4 squared is 16. And then 8/5 squared plus 11/5 squared plus 14/5 squared plus 17/5 squared is 26.8. Then I multiply that by 2. And when I simplify, I get 3/10 times 70.6, and that equals 21.8. So I am close to my value of 21. It's overshot a little bit. The trapezoid rule overshot. And so I would have an error of 0.8. So the error in this case for this trapezoid rule, my error for T5 of the integral from 1 to 4 x squared dx, the error would equal, the actual integral equals 21, and T5 equaled 21.8. So then my error would be equal to 0.8. Okay, if you have any questions, please let